Hello, my name is Mirae, and today I will be presenting my research project titled Ashwagandha-Infused Cheetahs and Nanoparticles, a culturally competent strategy to support mental health and brain cell integrity. This project integrates ancient medicinal knowledge with modern biotechnology to develop an affordable, culturally inclusive, and effective approach to supporting brain health and mental health, especially in underserved communities. So first I'll be going over the background hypothesis and then cell viability test, then the transwell system to imitate blood-brain barrier, then back to cell viability test, and then end off with implications and future plans. Ashwagandha is an evergreen shrub native to India, the Middle East, and northern Africa, and for thousands of years it has been used in Ayurvedic medicine for its stress reducing, anti inflammatory, neuroprotective, and sleep enhancing properties. It reduces cortisol, the stress hormone, and has been shown to enhance cognitive function and emotional resilience, which makes it a promising natural remedy for mental health support. And due to the increase in popularity of ashwagandha, there have been more ashwagandha incorporated products in the market as of recent. So there are ashwagandha ghee products, ashwagandha beverages, ashwagandha supplements, ashwagandha oil, and ashwagandha tea as an example. And however, while many commercial ashwagandha supplements exist, their true efficacy is limited due to one key biological barrier, which is the blood brain barrier, or the BBB. The blood brain barrier protects the brain by tightly controlling what substances can enter into the brain. And unfortunately, ashwagandha's active components have limited permeability across this barrier, meaning that when you take an ashwagandha supplement, most of it actually never reaches the brain where it is needed. And to address this, I explored the use of cheetahs and nanoparticles, a natural polymer derived from shellfish, which has been widely studied as a drug delivery system. These nanoparticles can carry ashwagandha's active compounds and help them cross the BBB more efficiently. By combining traditional plant medicine with nanotechnology, we can enhance ashwagandha's therapeutic potential while keeping it accessible and culturally relevant for communities around the world. So, my hypothesis is as follows. So, if ashwagandha extract is infused into cheetahs and nanoparticles, then its neuroprotective effects, measured by increased viability of human brain cells, will be significantly enhanced compared to ashwagandha alone. This approach could make ashwagandha also more effective as a complementary and alternative medicine, especially in communities where access to psychiatric care is limited or stigmatized. Um, so the hypothesis is by infusing ashwagandha into a drug delivery enhancing nanoparticle, specifically chitosan nanoparticle, ashwagandha will permeate the BBB with more ease while simultaneously having an enhanced neuroprotective effect. To test this hypothesis, I used a transwell system, which is a common model for simulating the blood brain barrier in vitro. It allows us to observe whether particles can cross from one chamber to another, mimicking drug delivery into the brain. So in the transwell system, we put the endothelial cells here and then the neuron cells to show like the ashwagandha infused cheetahs and nanoparticles permeating this BBB simulation. After confirming that the ashwagandha infused cheetahs and nanoparticles could move across the barrier, I evaluated their effect on human brain cells using a cell viability assay. And this measures how many cells survive after treatment and serves as an indicator of neuroprotection. To simulate oxidative stress, a condition often seen in neurodegenerative diseases, I exposed the human brain cells to hydrogen peroxide, which damages cells. I then applied three treatments. First, no treatment for negative control, ashwagandha alone, and ashwagandha infused cheetahs and nanoparticles. The group treated with the ashwagandha cheetahs and nanoparticles showed significantly higher cell survival rates compared to both the control and ashwagandha alone groups. And these results support my hypothesis that nanoparticle enhanced ashwagandha provides better protection to the brain cells under stress conditions. This study presents a promising direction for affordable, accessible, and culturally competent mental health interventions in the form of traditional medicine supplements. So rather than relying solely on expensive pharmaceutical treatments, this system could be developed into an over the counter supplement that is both effective and culturally relevant to many cultures across the world. And future plans include testing more human brain cell types to mimic the complexity of the brain and the blood brain barrier, optimizing the ratio of ashwagandha to chitosan for maximum effectiveness, investigating shelf life and scalability for large scale commercial production, and exploring metabolism rates in human models to evaluate safety and efficacy. This could lead to new tools in mental health care, particularly in low resource settings or in settings where psychiatric or mental health care has sort of this cultural resistance. In summary, this project bridges traditional medicine and modern nanoscience to offer a novel solution for improving brain health. And by leveraging the benefits of ashwagandha and enhancing its delivery through cheetahs and nanoparticles, we aimed to develop a treatment that is effective, accessible, and respectful of cultural practices. Thank you very much for your attention, and I welcome any questions.